We now move on to the realm of machine learning with a presentation on behavior-based quality assessment of OpenStreetMap data in data-scarce areas using unsupervised machine learning by Maruf Ahmed. This focuses on Dhaka in Bangladesh and is concerned about the reliability of data and contributor behavior. So let's hear it from our second presenter.
Good afternoon everyone, I am Maruf Ahmed from IWFM Buet. Today I will share how we used behavior-based unsupervised machine learning method to assess OpenStreetMap data quality in Dhaka. Let's begin by understanding why this work is needed. As many of you know, OCM data quality can vary greatly from place to place. However, cities like Dhaka often lack authoritative reference datasets, making external validation very difficult. Therefore, the objective of the study was to design an intrinsic quality assessment that relies only on contributor behavior and unsupervised machine learning. Now, this is the study area. The Dhaka Bangladesh I chose as the study area because this is the fastest growing megacities in the world. Now, let me walk you through the methodology step by step. So here is the 6-step pipeline that I followed for the methodology. First of all, data extraction. I downloaded the latest Dhaka OCM PBF file and used the PyROCM library to extract all roads and buildings edits. Next, behavioral feature engineering. For every unique contributor, I calculated a rich profile of 8 metrics, and in this screen you can see the all 8 metrics. And for pre-processing, I filled any missing values with zeros and applied J-score scaling to balance the feature ranges. For dimensionality reduction, I choose PCA analysis, and for clustering, I choose KMeans and HDBSCAN method. And for validation, I analyzed edit, volume over time, and feature distributions per cluster to interpret behavior and infer data quality. As I told you that I applied PCA analysis. For PCA1, it represents global mapping activity, and PC2 captures thematic focuses, roads versus buildings, and PC3 reflects spatial coverage. And this step not only reduced noise but also revealed which behaviors drive contributor differences. So in the left figure shows that contributor activity intensity is the strongest behavior of variation, followed by thematic preferences and spatial footprint. Once we had those components, it's time to group contributors. I ran two unsupervised algorithm, KMeans with k is equal to 4 and HDBSCAN. KMeans achieved a relative score of 9.51, showing clear and stable clusters, and HDBSCAN was helpful for spotting anomalies but produced less distinct groups. So KMeans was our primary model. For this clustering, I identified cluster 0 casual. Cluster 0 means casual or one-time mappers, often from hackathons or large imports. Cluster 1 and 2 moderates or heavy contributors, steadily active with richer semantic tagging. And cluster 3, the power users, few in number but with high edit volumes and wide geographic coverages. Clusters with frequent, recent, and thematically focused edits consistently produced higher quality of OCM data. That critical insight for prioritizing validation efforts. And next I checked edit volume over time and feature distribution to validate the clusters. And so in summary, behavior-based unsupervised machine learning can reveal intrinsic OCM data quality without any external references. This transparent and extensible approach is ideal for data scarce regions and can support NGOs or OCM community to prioritize validation where it's needed most. Looking at this framework could enable longitudinal monitoring of contributor quality worldwide. So thank you for your time. Thank you for listening.
Thank you to Maruf Ahmed for that presentation that focuses on how the analysis of features and clustering associations resulted into the findings that recent, frequent, and thematically rich editing were also responsible for high quality contribution. So this is one of the significant findings of the paper presented to us by the author Maruf Ahmed.